Hi, welcome to Undoubtme. In today's video, we are going to learn transformation of functions. Now, transformation of functions is a very important topic from the examination point of view. Plus, if you're aiming for mathematics at higher level, for higher grades, then to understand function graphically and to understand the variations in the graphs of a function, this topic is very important. So please watch this video properly, and if required, you can watch it multiple times. So let us start with transformation and let us try to understand that what it is all about. So when I say a function, when I say transformation of a function, so what does that mean? Usually we take function as y is equal to fx, okay? And transformation means that we can shift it either up, down, we can horizontally stretch it, we can compress it, okay? So these are basic transformations for a function what we can apply. All these transformations can be better understood with the help of graph. So I'll show you a few graphs and I'll show you the variation in the graph, that how it will change. So now we'll start with the very basics. And what is the basic part? So let us see over here. If I say y is equal to fx as a function, then y is equal to fx as a function can have broadly two types of transformation. One is known as horizontal and one is known as vertical. Now when I say horizontal and vertical, so in that we can either shift them, so we can call it as horizontal shift. Horizontal shift will be either towards the left or to the right for a function. And when I say vertical, so in vertical also I can involve shift, and this shift will be either up or down. Horizontal shift will be towards the right or towards the left. It can be either ways. How it is, we will see it in the video, so stay tuned. One more type of transformation in horizontal is, we can call it as stretch. Now stretch means horizontally we are trying to stretch the function, okay? Now this stretch can be done by either compression or by expansion, okay? Both the things will be categorized under stretch only. So I can say that the stretch will cover either compression or it will cover expansion, okay? In vertical also, the second category of transformation is stretch. And in stretch, once again I can say that either it will be vertically compressed or it will be expanded. So I hope that till here you guys are clear and you have understood. Now we'll see one by one the example for horizontal shift, vertical shift, stretch and compression. Okay, let us see each one of them step by step. So I will be talking about horizontal shift. Okay, now right now it is horizontal shift, and shift means it will be either leftwards or rightwards. Okay, how do we understand that? Let us see over here. So if I have y is equal to fx as the original function, if I have y is equal to f of x plus a as one of the transformed function, and if it is y is equal to f of x minus a as another transformed function, then it is quite visible that f of x plus a is the transformation of fx, okay? Now how to know that it is shifted towards the left or towards the right? So all what you have to do is, you have to look for this factor. It will always be in the question, in the function, like over here it is x plus a. You have to just put it equal to 0. When you will put it equal to 0, you will get a certain value of x, and over here the value of x is negative a. Now just use your common sense and think that where this x is equal to negative a can be. It will be definitely towards the left. So I can conclude that f of x plus a is shifting the function or the graph towards the left. Okay. Similarly, let us analyze the next case. In the next case, it is x minus a, we'll put it equal to 0, the process is same, and that will give me x is equal to a. Now x is equal to a, just use your general understanding and think where it should lie. It should lie on the right. It will lie on the right, so I can say that the graph is shifted rightwards. Okay, so it is as simple as this. I hope this horizontal shift is clear. Now it is time to move towards vertical shift. So vertical shift is basically for a function like the shifting in y values. So it will be either vertically upwards or it will be vertically downwards. So if I just compare, then horizontal shift was actually happening on the x-axis left right, vertical shift will happen on the y-axis up and down. Okay, let us see how it is. So if I have the original function as y is equal to fx, if I have one of the example as y is equal to fx plus a, where a is any number, and if I have y is equal to fx minus a, now all what you have to understand is when it is plus a means you are adding something to the value of fx. Value of fx lies on y-axis. Since you are adding something to the value of fx and it is plus, so I can say that this will be vertically upward shift. Okay, listen to whatever I said carefully. If you want, you can just rewatch that part of the video, but this is the only thing which you have to apply in all similar type of questions. Similarly, the other one is fx minus a. Now fx was the, like we can say it is the reference. If it was fx plus a, it was going upward. So if it is fx minus a, it should go downward. It is as simple as that. So the transformation in this case will be vertically downward. Okay, we can understand this thing with the help of any example. You can refer to some graph drawing websites like Desmos, and other websites are also there. And over there you can take any example, try to apply the similar logic, and you can check the graphs over there very easily. If you want me to make videos on those graphs, you can put it in the comment. I will definitely make a video on that as well. Now it is time for stretch. Now when we say stretch, so stretch can be either compression or expansion. Okay, right now I'm talking about the vertical stretch. Okay, now what is the meaning of vertical stretch? In vertical stretch, basically we are amplifying the value. Now this amplification can take place positively or negatively. So even we can do the amplification in a negative manner, means the value can be reduced. Okay, as you can see, I'm saying value means y. So the vertical stretch is actually applied when I multiply a number along with fx. Okay, it means that the whole value of fx is being times by something. It can be any number. Now it is quite obvious that if this a is greater than 1, then that will be vertically expansion. Expansion means the main value of the graph, or overall all the values of the graph, will be times by that multiplier. Let's say if 2 is that multiplier, then every value will become twice. Simple. Similarly, if the value of a is between 0 to 1, then the value will be actually compressed. So that is vertical compression. So with the same transformation y is equal to afx, we can understand both expansion and compression. Examples can be any, it can be applied on any random function. So as I said, if you want to have a video on that, you can put it in the comments. Okay, now we are moving on towards the horizontal stretch. That is our last transformation. So this is also of the category of stretch, but now this stretch is horizontal. Now what is the meaning of horizontal stretch? Horizontal stretch means either it will be expanded or compressed horizontally. Okay, how does it look? Let us understand. So if I take y is equal to fx as the function, and if I just write y is equal to a f of ax, means that a, which was multiplied outside in the previous case, now it is being multiplied inside. That is the only difference, as you can notice. Okay, so based on the value of a, if the value of a is greater than 1, now over here the things are a bit different, so try to understand it carefully. If the value of a is greater than 1, then that will lead us to compression. Okay, to understand this better, you can take any example. You can take an example of y is equal to sin x, put it in the graphing calculator, and then you make a graph of y is equal to sin 2x. You will understand that y greater than 1 values are creating compression. So it will be compressed by a factor of a. Let's say if I'm saying y is equal to sine of 2x, it will be compressed by a factor of 2. Okay. Similarly, if the value of a is between 0 to 1, then it will be expanded by that factor. Okay, expanded by that factor. For example, if I have y is equal to sine of x by 2, so this is 1 by 2, the value of a is 1 by 2, so that graph will be expanded by a factor of 2. So we can say that time period, frequency, everything will be changed according to that. So this ends our transformation. I hope that you guys are clear with what we discussed over here. These were very important and all basics of transformation. Everything in the transformation is covered in this video. So you can watch this video multiple number of times and do share it with your friends. And if you like this video, then you can mention whatever you feel in the comments. Plus, consider subscribing the channel to watch more of such videos in future. Thank you.